Hi everyone, so I am Rose Hoffman and I will be bringing you through problem number 5 in section 1.8. So problem number 5 is actually just a continuation of number 3. So they had some initial conditions that I rewrote right there, and then it also told you to assume that the resistance is proportional to the square of the velocities, which means that this equation written here is true. And then our goal, I wrote at the very bottom, is to find position at time 60 or after minutes, because we want to find the distance that a motorboat travels a minute after the motor quits. So looking up into the top right here, I have an equation written. This I found on page 93 in your textbook, and it's just going to be helpful in solving our problem here. So I just brought over our initial velocity to begin writing out our equation here. So 40 over 1 plus 40 times k to the t. So that is our velocity as a function of time. And I'm just going to begin by solving for our k value by bringing over this other condition of velocity. So writing that in, you'll get 20 equals 40 over 1 plus 40 times 10 to the k. And I'm not going to solve k all the way through. It's just some basic algebra. And you'll get k equals 1 over 400. Now I'm going to bring that value back into our initial velocity up here. So 40 over 1 plus 40 times 1 over 400 times time. Now I'm just going to do one more step here. I'm going to multiply both the top and the bottom, numerator and denominator, by 10 to clear some of those fractions. So when you do that, you should just get 400 over 10 plus t, which I think is a lot easier to look at and figure out how to solve. So since our goal is to find the position at time 60, I think it'd be good for us to have a position function. So in order to get a position function, we are going to integrate the velocity function. Alright, so as I was saying, we're going to integrate both sides, and when you do that, you're going to get the resulting position function. Now integrating this right-hand side, I don't know if it's easier to see it as 1 over t, but anything over a function of t to the first power is just going to be the natural log. So that side will be rewritten as 400 times the natural log of the absolute value of 10 plus t. And then also do not forget your constant c, because that's important in our next step. We're going to solve for c and then continue on. But I guess the real question here is what initial condition are we going to be using? So this, I'm just going to write this down. Hopefully this makes sense. So I just assume that at position 0, or at time 0, our position is 0. Which makes sense. We're starting at our initial time is 0 and increasing the distance as we go. So using that condition, I solved doing this. So 0 equals 400 times the natural log of 10 plus c, just plugging in 0 for both the position as time of t and time functions. So then your c value is going to equal negative 400 times the natural log of 10. Now, like I did before, I just brought that c back into my initial equation, my initial position equation. So rewriting that equation from above is going to be 400 times the natural log of 10 plus t minus 400 times the natural log of 10. And now I'm just going to further simplify this by pulling out a 400. Throw it on my brackets. It's the natural log of 10 plus t minus the natural log of 10. And now there is a property of logarithms that says when you have the subtraction sign in the middle, I can just divide them. And so I'm just going to rewrite that function down there like this. So it's times the natural log of 10 plus t over 10. And so that's our position function, simplified down right there. So now at this point, real simple, we wanted to find it at time 60, so we're just going to plug in 60. So you'll get 400 times the natural log of 10 plus 60 over 10. And now you're just going to plug this right into your calculator, and the final answer that you should get is 778, this is feet. So this is the answer to our problem. The motorboat, a minute after the motor stopped, it traveled 778 feet. So hopefully that cleared some things up for you guys. Thanks for watching.